Let's explore integer exponents. Let's begin with a good example. Powers of 2. 2 cubed. By this we mean, of course, 2 times 2 times 2. 2 multiplied with itself 3 times, which we know equals 8. Let's reduce the exponent by 1. 2 squared. 2 times 2, which is 4. Let's keep doing this. We get now 2, and 2 to the 0. Let's see the pattern. We went from 8 to 4 to 2. So each time we are dividing by 2. So in this natural progression, we get 2 to the 0 equals 1. Similarly, 2 to the minus 1, if we keep dividing by 2, it would be 1/2. 2 to the negative 2, 1/4, which is 1 over 2 squared. 2 to the negative 3, half of 1/4 is 1/8, etc. So this lets us define, or this shows us the relationship between, shows us two things. First is that a number to the 0th power, we want to define it as 1. And that a power is equal to its reciprocal with the sign changed in the exponent. So let's write these up here, the laws of exponents. And these laws, m and n, are integers. So here the first one is that a to the 0 is not equal to 1. Or a to the 0 equals 1 as long as a is not equal to 0. And the second one, as we said, is that a power is equal to its reciprocal with the opposite sign in the exponent. Let's continue. There are more laws of exponents. Here we have that a product of powers is equal to the power that has the sum of the two exponents. And a quotient of powers, a to the m over a to the n, is equal to a to the difference of the exponents, the top exponent minus the bottom exponent. And you can write this as 1 over a to the exponent with opposite sign, which turns out to be n minus m. Here, a power to another power is equal to a to the exponent m times n. We multiply the exponents. Here, the power of a product is equal to the product of the powers. And a power of a quotient equals the quotient of the powers. Here we need b non-zero. Now let's do an example. Let's do this example. So this is problem number 76 in section R.2. Simplify the expression -4 to -2. We have to remember what this means. The negative sign means multiplication by -1. So we're multiplying, we have the operation of multiplication, and we have the operation of exponentiation. Now you don't want to think of this as -4, that to the exponent -2. It's correctly interpreted as we do the exponentiation first, and then the multiplication. Remember, PEMDAS. Exponentiation before multiplication. Let's completely simplify this. What is 4 to the minus 2? Well, we saw that power is equal to its reciprocal with the opposite sign for the exponent. So this equals 4 to the negative 2 equals 1 over 4 squared. 4 squared is 16, so we have minus 1 over 16. This is our final answer. Most simplified form. Let's do another example. Simplify this expression. We want to simplify it as much as possible. And the instructions say to use only positive exponents in our final answer. This is a fairly complex looking expression. We have lots of exponents going on. Let's see what simplifications we can make using our laws. First, let's deal with this part right here. Let's have only single variables to powers in our expression. So we need to deal with this power of a product. The law said that a power of a product equals the product of the powers. So we essentially distribute the exponent. And now we see that we can, for example, let's separate these. And then we'll apply the law that deals with the quotient of two powers with the same base. You only a single power is the unit. Let's see. Let's do these individually. 4 over 2 cubed. Well, 4 is 2 squared. And we saw that when you have the quotient of powers, you can, with the same base, you can write this as same base, the exponent, the top one minus the bottom one. So this is 2 to the minus 1, which is 1 over 2. And then here, you apply the same law. And let's go the other way. You can write this as, you can write it with the power in the bottom. But here you have to do the opposite order in your subtraction. You do the bottom exponent minus the top one. So here we get x to the negative 2. And since we'll leave it like that for right now. And then finally, y to the minus 1 over y to the 1. This is y to the, we'll go back to the way we did it with powers of 2. The top exponent minus the bottom. This is y to the minus 2. Okay. And now let's put it all together. Let's erase this. We'll write it over here actually. We've simplified each of these individual factors. We've simplified them to, this was 1/2. This was 1 over x to the minus 2. This was y to the minus 2 and z to the minus 1. Okay. So now, since it says use only positive exponents in your final answer, let's eliminate all the negative exponents. This 1 over x to the minus 2 becomes simply x to the positive 2. This becomes 1 over y squared. This becomes 1 over z. So now writing this as single quotient we have for our final answer. We have x squared on top, 2y squared z on the bottom. And that is our final answer. In most simplified form, and we use only positive exponents.